All right, so guys, this is a good stopping point, not forever for today. This is a good place to pause. So I'm going to go top off my coffee. I don't want to do a super long pause because your graded assignment on Thursday are problems that look just like these two. So this is my way of taking you through everything that you need to do so that you know what you're doing on Thursday. So I'd rather get done early than us not get through the two examples that you need. Does that make sense? So can we say we'll all be back in our seats at 8:43? Okay? Ms. Meister's going to go top off her coffee because, it's cold outside and it was hard to wake up. And I'm going to pause that recording too. All right, so let's go ahead and say that Mr. Richards claims that he is a 70% free throw shooter. Would you? No? Take foul shots in basketball. No. Just so you guys know, Miss Meister is roughly a 10% free throw shooter. She real bad. Real bad. When I played basketball, if I shot the ball, my coach pulled me from the game. He said, you need to understand your role on this team, and shooting isn't it. It's not.
I don't understand your role. That's so bad.
Well,
I don't think I would recover from that.
Were you called toothpick, though?
no. Now, my job was to break the press and press because I had legs that would go forever. My legs never got tired. So my job was to run all over the floor and be a pain. Shockingly, I was very good at being annoying. No. Okay. So, guys, when we're writing our hypotheses, our null hypothesis is always going to be that whatever the claim is correct. So in this case, it would be that Mr. Richards' ability is equal to 0.7. Now, you need to write the P equals. It's not gonna feel like you need that now, but it does actually make a difference later on down the road. Okay? Because we're not just going to learn tests about P, we're going to learn tests about mu. And so understanding that there is a distinction is important to me. Is everybody okay? All right. My alternative hypothesis is what we're hoping to find evidence of. So if I think he is overstating his abilities, do I think his overall success rate is lower or higher than 0.7? Lower. So my alternative hypothesis is going to be that P is less than 0.7. How are we feeling about writing hypotheses? Does this feel okay? All right. Let's describe the P hats. We're going to assume H0 is true. The null is true. So, my shape is going to be, and we have a sample size of 50. So my shape is going to be 50 times 0.7 and 50 times 0.3. That works out to be 35 and 15. So, what do you guys think? Is that a good thing? 35 and 15?
Normal.
They're greater than or equal to 10, so we can say that the normal condition is met. Okay? What about the center of all those P hats? I'm going to do something real quick. It is 0.7. I just want to do it in a different color. So the mean of those P hats is 0.7. The standard deviation of the P hats is the square root of 0.7 times 0.3 all over 50. And hopefully these formulas don't feel that icky because you've used them before.
.065.
0.065. Okay. Now, what was the actual observed percentage of our sample with Mr. Richards? Well, that was, he made 32 out of the 50 shots, yeah? So it would be 32 out of 50. So he shot 64%. Now, is that enough for us to say, oh, he's lying?
No.
Does that convince us that, oh, actually he's doing worse than 70%?
Yes.
That convinces you?
It would be closer if you said 60%. Because of rounding. It does not convince me.
It doesn't convince you? I don't know if I'm convinced. So what I'm going to do is find the test statistic and p-value to see how unlikely was it that this happened. Okay? So that z statistic, we call it the test statistic, we're going to find the z-score for this. And a reminder, the z-score is equal to the actual minus the mean divided by the standard deviation. Okay? What was the actual thing that happened? The 64%. He made 64% of his shots. What's the mean? The standard deviation? Do you guys, does this make more sense to think of it this way? Yeah. What's up, Delaney?
Oh, I don't know why I was raising
Okay. What are we getting? Negative 0.92. Okay. All right. So we find our test statistic. Okay. Next step. We find that p-value. That is a normal question, so we're going to draw normal with a mean of 0 and a standard deviation of 1 because we did z-scores, and z's have a mean of 0 and a standard deviation of 1. Our observed z-score was negative 0.92. And then we're going to shade our graph the same direction as our alternative hypothesis. So in this case, I'm going to shade to the left because my alternative hypothesis is less than. What's up, Matt?
I got negative 10.
You did probably 0.65 instead of 0.065 for your standard deviation. Oh, no. You have to be really careful because it did 0.7 divided by this first. So you need to use the fraction bar to do it so that it does the right order operation. All right. Did you guys put this in the normal CDF? What'd you get? 0.18. All right. Now, 0.18. And then what you're going to do is you're going to say, how does that compare to alpha? So a reminder about alpha. Is this probability lower than this particular alpha? No. It's bigger than 0.05. Okay? Now, we typically use alpha equals 0.05, but not all the time. And we'll talk about that a whole lot more on Friday. Okay? So should I rule out the null hypothesis then? Feels like my sample is actually pretty reasonably likely. Okay? So we can't rule out the null hypothesis, which means we can't refute his claim. So you're either going to rule out the null hypothesis if that p-value is lower than alpha, okay? I'm kind of do a little sidebar here. So if your p-value is less than alpha, we rule out the null and conclude the alternative. If your p-value is greater than alpha, you cannot rule out the null. So you can't conclude anything because both hypotheses could still be true. Which is probably pretty good because I don't want to be the one to go over there and call Mr. Richards a liar. He's scary. So these are your, you're going to think about this as making a decision about the null hypothesis. And you make that decision using your p-value. What do you guys think? Is this bad? Can we do another one? Then we're done? I'm going to give you guys a second to finish writing this out. We ready? Looks like a few people are still reading. What do you guys think about the null hypothesis this time around? What is it? Is what I was going for. P equals 0.2. It's all of it. It can't just be the 0.2. It's got to be what's the parameter. In this case, it's a P because it's a population percentage. Equals 0.2. All right. And if we look at our sample, we got 29 out of 200, which is 0.145.
I see what you mean. I really thought you were asking after the last problem, like how do we feel about it? So I was just doing those thoughts.
All right. What does our sample suggest as an alternative to P equals 0.2? Less than or greater than? Less than. So my alternative is going to be P is less than 0.2. Okay. So now we're going to do our shape center spread. Let's see. We're going to do 200 times 0.2, 200 times 0.8. And I get 40 and 160. Those are bigger than 10. So we can say the shape is normal.
Will there ever be a time, like soon, when it won't be normal?
No. It is important to me, though, that you check for the normality. Again, laying groundwork for like a future statistics class. What about the center? Huh? 0.2. And the standard deviation? You getting it?
0, 2. And I don't just have it around the numerator this time.
It's just 0.02?
0.028.
Okay, cool. All right. Our statistic is p hat, which was that 0.145. We already got that, okay? Our test statistic is the version of it, okay? So we're going to do 0.145 minus the mean, which is 0.2, divided by the standard deviation of 0.028. And what are we getting?
Negative 1.96.
Negative 1.96.
96.
Okay. All right. So now to find our p-value, and draw that picture. Normal, the mean of 0, and a standard deviation of 1. Negative 1.96, and then to the left, because it's less than. So our p-value would, I'm assuming you get 0.025?
Yeah.
Wait, so normal CF, would your lower boundary be?
Negative a gajillion.
Okay.
How did you do that in your head?
Do you guys remember when we were doing those, finding the z-scores for like 95%, 99%? The z-score for 95% is 1.96 with 5, so that would be 2.5% in each tail.
Gotcha.
So I didn't, it's just something I have memorized. And how does that compare if I used alpha equals 0.10? Is it bigger than alpha or smaller than alpha? Smaller. So what does that mean? Can we rule out the null hypothesis? Can we say, hey, we shouldn't have been able to get this if the null hypothesis is true? Yeah, it's unlikely to happen when the null hypothesis is true. So we can rule out the null hypothesis. Therefore, we can say less adults smoke. Because that's what the alternative hypothesis says, right? P is less than 0.2 means that the proportion of adults who smoke is less than 20%.
I feel like the number could change though depending on where this survey was taken.
Sure. So who your sample is allowed to represent is an important question in that, like, if I take a random sample of you guys, I can represent you guys. If I take a random sample of kids from the school, that can represent kids from the school. But walking down to study hall is not taking a random sample of kids from the school, particularly at the beginning, particularly actually on a block day in general. There are a lot less kids in study hall on block days than on other days because study hall always is butts up with either against lunch and kids go home to have the longer lunch, right? There's less kids in study hall on block days. For sure. What do you guys think about this? Was this okay?